Okay, so check it out. I'm now going to be playing with this equation. Consider the equation 4pH3 goes to P4 plus 6H2. In a 2-liter container at T equals 0, ooh, I had some poor spelling there. There are 0.1050 moles of pH3 present. 0.1050 moles of pH3 at T equals 0. That means time is 0. Okay. After 1 second, 0.1002 moles are present. What is the average rate at which each of the products are created? Oh boy, this sounds tricky. At which each of the products are created. Well, I know that the speed at which the reactants disappear over time is equal to the rate at which products appear over time. So, if I find how quickly the reactant is changing, I can figure out how quickly the products are being formed. So I'm going to come here and I'm going to say the change of the concentration of the reactants is in moles per liter, and I know that based on what I read in the Fast Track 205. So I can come in and say at T equals 1 second, just put it up here really quickly. T equals 1 second, there is 0.1002 moles of pH3 present. Okay, so how much did it lose? 0.1050 minus 0.1002, which is 0.0048 moles, right? For every second. But I don't want moles. What do I want? Moles over liters. How many liters do I have? Yeah. So 0.0048 divided by moles divided by 2 liters. 0.0024 molar pH3. That's how much is lost for every 1 second. Now check this out. Isn't that exactly this right here? Right? Because, so that's the, well, I know that negative means loss and positive means gain. So I could say for every second, 0.0024 molar pH3 disappears. And I can take that rate and convert it into products. 0.0024 molar pH3 times, for every 4 moles of pH3, 4 molar pH3, there is, for 4 moles of pH3, there is 1 mole of P4. So this guy cancels out, and this guy cancels out. And moles cancel out, and I get 0.0024 divided by 4, which is 0.0006 molar of P4. That's how quickly P4 is being created. And for H2, I do the same thing. 0.0024 molar pH3 over seconds times 4 moles of pH3. And let's see how much the other one we're creating. 6. Cool, 6 moles of H2. Now when I cross moles out, pH3 out, my answer is going to be 0.0036 molar H2 per second. Is that right? Did I do that wrong? Yeah. Should be right. If my math is correct. And I'm done. That's how quickly both of those are being made. Boom. Problem solved. Yes, ma'am. So I took 0.0048 moles and divided it by 2 liters to get molar. Because molarity is equal to moles per every liter. Where'd I get what from? 1 second? Oh, because it said at t equals 0, there's this much. At t equals 1, after 1 second, that much. That's why I initially subtracted these two values from each other to get how much is decreasing for every 1 second. Sure. Okay. Right here? Right here?